Okay, so this is going to be video 2 on that one. I did the other video, but he just dropped this one. Like, they were back to back, maybe yesterday or earlier today. He was working on it, and they kind of work together. But a quantum particle is described by a wave function. Okay, what people sometimes forget to understand, or at least one of the reasons I think I do well in this field, is because I do pretty good with geometry and measure theory, right? So a wave function is essentially to say light, a particle traveling 99.999% the speed of light, or one that's traveling negative 272.9999999 Kelvin forever. Somewhere in there, there's roughly the 2.72 approximations, 0.005 up or down degrees Kelvin, which is just slightly above zero, right? Because a negative and a positive, whether Kelvin or otherwise, there's a zero bar in there. And that's kind of really important to all this stuff. And later on, sometimes that zero bar changes in relative to operations. Like, this is going to be very hot before she starts to redshift or microwave visible light right about 3.14, which is 20 or 7 divided by 21, right? Because 7 times 3 is 21. So it gives you an extra. If you did 7 times 2, that's going to get you that 3.1415, somewhere between 3 and 3 1/4. Not that that number is relative. It all happens in this zero field, which is why you can't really use letters or numbers that way. Okay, so let's give another example of what this looks like. Here's some figuring it out problems. What we're talking about here is distance, this total 1 0 to a half an inch, this geometry. It's a tube, if you will. Let me show you. It is a tube, and I recommend this guy in his garage. He did a great job. He showed it up. He did a lot of like the computer integration of editing in the software, and he had that really good home style version, like online blue plate paper like that. I love that kind of stuff. Yeah, description of life: staying far enough away from death, and that's probably a good apt description. And if you had to figure out all this magnet stuff, and you were working not just that, but you had to do the coding there, that here, what we're talking about is this metrics we're about to make. This is all going to be squishy and compelling with each other. The very highest energy state, their lowest energy state, Big Bang, or at least me talking right now in the Laplacian, is going to always start to wave function out. From the start, I could go farm. I could go computer engineering. I could use to say that to the farm, if I operated really quickly with latitude and line, that I could bring the horse kick to joules for the farmer. But in terms of order of operations here and how you're describing it, the only way is to 0, 1, 1, 2 that way. So what you get is this third dimensional field, and then that'll turn into like a fourth dimensional object because my center of mass is moving around the building. It's affected by swings and magnetism in the building. And again, you can determine that by saying, well, that is the programmer's class of the wave function is described by that number or that point, if you will. And those points in their entirety are become a point. So you'll get this Gaussian thing going down. It'll start to have a torus or kind of surface problem on the mass shell like that. Well, it could split and have vibrations either way. Let's see what else I got. A lot of times, again, here I did the Schrodinger's product integral rule. I just write that up in the mill, on my whiteboard next to my saw cuts and what I needed or how I'm finishing off the order. And like a 10-foot tread, that's what I need to approximate inside of here. And I'm going to have a bunch of different values about how to argue the probability of that frame x to equal 0. That means I'll close loop that inside of the day by the block and how it takes to cut them during the day. How that cosh, or that angle, 30 degree, 30 cosh, cosecant or something like that, that those other models in an A form or a derivative are the same object. Like this is going to be in superposition as far as that wave function. Now we're saying that the wave function is cosh x, is basically fx again, or wave function x, or wave function y. It's a little hard on the brain as far as order of operations not to do that, and it's more so harder here because it's too analytical, it's too Marlar, it's all ones and zeros trying to figure out a pattern out of it, right? You got to change the frequency from f1 to f2 so you can take that whole wave function, and just see what's going down in this little section of it, and then determine that to help you Fibonacci that issue, which is 0 plus 1 equals 1, 1 plus 1 equals 2, 2 plus 1 equals 3, and so on and so forth until apparently you get out to like 233. But at any rate, you're kind of watching that going down. And what I wanted to reference is when you see pi 1, what we're looking at here is this diameter. That's what that tells us. But that's because we're not really sure of the diameter. We're not sure about that length. We're not sure about where did my those measurement theory go. But what's happening is there's beta radiation pulled off, alpha radiation, or alpha and beta radiation in an electron. Or actually, I think this one orientated as the electron because it curved so hard. It's the lightest of them, I think. The alpha is the heaviest and the beta is the weakest. Well, look at what just happened here. Whether you say it's this point to this point, with a little bit of skittering off there, this electron, but then this set starts again, and it has these other two parts to it, and it has this other two parts for it. But as you observe it, what you see, as far as what I can determine, is what this is. Now, you take that in your computer, and let's say we were going to program. Come on now. We wanted to get into either form of these programmings, but let's keep it simple. Hello world. I don't really know if this is the best thing to do. I mean, because of the limit of this is generally what it starts with, but this is what we have today. We're already skipping a bunch of steps. To do C program, C out to C++, C, C++, there's really important steps of order of operations that this doesn't provide, but it provides that metrics for. We don't really have the second order operation is here before I start to change that to quarters or the fourth dimension. Let's change the object. Let's take that third dimensional field, and the computer already has it in kind of superposition as long as it doesn't start to glitch out ragdoll physics. And that could be relative to the human side of that there, the corporeal form. So that was just a topic I wanted to touch on in here. I'm sure there's a lot more to it, but it gets into that 1 pi, pi r squared, geometry. Let's make a circle with a computer programmer so we can define the wave function and do useful and interesting work. I mean, we should be able to almost compel not necessarily the working joules to that, but the radius of the MOB of some general's desk if you drop that correctly. So, catch you on the next one.